Hello and welcome. Sanjin here with Stuffy again. This is our 8th session together overall, and we are continuing with PicoCTF. Today, we are going to be working on binary exploitation. Now, if I'm more accurate, Stuffy is going to be working on it. I am very much in the driver's seat, in the passenger seat for this one. Before you get started, remember, try every challenge first. If you've been stuck on it for a little while, that's really good for you. You will remember the solution. And finally, if you have solved it, by all means, look at multiple walkthroughs. We certainly have for these. Binary exploitation isn't easy, and getting multiple perspectives is good for you. Okay, Stuffy, take it away.
All right, so let's go look at basic file exploit. All right, so they're hosting the file here, and it looks like it says try playing around with it and we can break it. So we're going to connect with netcat. We see that. And then the hint here tells us try passing in things the program doesn't expect, like a string. Okay, perfect. So let's go ahead and look at this and see if what we get here. So, okay, so we get welcome to my echo chamber. Okay, so since we're in an echo chamber, let's go ahead and try and echo something. Okay, and you see that we can't enter anything because there is no data in the database. Okay, so let's
enter something on number one.
So we're going to put something in the database. I don't really care what. And the length, we'll just do 4 because just to make sure. And then it says, would you like to do anything else? So now we want to echo something. Okay, so now enter the entry number of your data. Well, it tells us here that try to enter something it doesn't expect, right? So it's going to expect me to enter our entry number is 1. So let's enter something it doesn't expect. Let's say hi. And boom. So what just happened on the back end, right? That's what we want to figure out because we have the flag. So let's go ahead and enter the flag and then we'll talk about what actually happened.
And by the way, everyone, I mean that this like button is red there, and so is mine. And
yeah,
it was unfair because we're going to look at the code and it's not that easy to understand at all. So the challenge is very easy to break, the code, not so much. But if we sort of trace in where the flag is printed, so Stuffy's going to go through there and we're going to find the line that prints the flag and trace how we get to that. We are going to understand a little bit about how to break this and get the flag.
Yeah. So let's look for the flag. And it looks like I thought I saw it there.
No, well, the data, it's in data.read function. It's the words the top printf sub.
You saw it? Timed out printf data.write
exit printf goodbye. So it's not here. Please put in a valid length. That's a validation function.
Yep. So that's looking to make sure that we put something legit in there.
If you just search for flag, you'll find it.
Yeah,
like Control F.
Yeah, I was going to do that, but I was hoping we'd run into it. Okay. So there it is. Okay. So there's a couple of hints here, I guess, or keys that we need to look at. So this is how we're going to get the flag, right? So if the entry that we put, which is that after we hit that 2, if we can enter something that equals 0, right? That's the goal. We want to equal 0. Well, there's a key function here, this strtol. So the way this command works is in C is basically it's looking for specific integers 2 through 36. So it's looking for those specific integers. And if you don't put those specific integers, like if you put a string, for instance, like the hint tells us, it automatically will default them to 0. Okay. And that's the vulnerability in this code. So that's why the key is to enter a string, right? Because no matter what string you put, it's going to baseline it to 0 because it doesn't understand it. Well, yeah, go ahead.
So if I'm pretty sure though, basically this function evaluates numbers like the string numbers you enter into essentially an integer of a long size, but there's also I think it'll evaluate 0 as 0. So I think our options are to enter any string, even one character, or to enter a 0. So like if we can test it out with a 0, funny thing is both Stuffy and I got it by typing in flag.
Did we lose it?
Yep, there you go. Hit it. Oh, no.
It's not there we go.
Oh, yeah, there we go.
So we got to, again, we have to enter something into the database for it to accept it. So we'll just say whatever. Okay. And then would you like to do anything else? We'll go ahead and echo. Now, like he said, we can enter any sort of characters, but you can also hit enter 0 because it's trying to say here, you'll see it. Where do we go? Here we go.
Yeah.
We need that to equal 0. So if we just put 0, it equals 0 then, right?
It converts it to an integer. Like it basically, 0 is a valid integer value. But if it's not a valid integer value, then it makes it 0 anyway. So yeah.
Yep.
That's, that little bit of like these 2 lines of C code. And by the way, if I can just trace this, if you could scroll down, the function where this happens actually, if you scroll up a little bit, this is like an infinite loop, but this is the main function that it happens in. And if you scroll down, that's the flag. I want to see what function the flag is in. So if you scroll up maybe to the top of the, no, down now. The flag was the function on top of the flag.
Oh, right on top of it.
That was the data read function. So now all you need to know to make sure that this if statement will get called is you got to find the data read function. And I know that it's going to be somewhere in the main because it gets called directly. So you will know when it gets called. So scroll down and look for the data read in main. There it is. I see it.
Data. Yep, right there.
So data read, and you can see that it's there inside the option 2. So you could have gotten there purely through the code. Us were both tinkering types. So we more or less stumbled on it. But yeah, as you can see, the option 2 gives you the data read. The data read gives you as the option to give you the flag.
Yep. You can see here what he's saying is this 2 option will continue to the data read function, which is what we need to call on it. So like he said, you could just have analyzed the code first and traced it, and then you'd have known it's in function 2. But if you are like us and you spend 2 minutes, you can just kind of stumble upon it yourself. So, all right. So that one was pretty easy, but also pretty complex.
Yeah.
All right. So let's go back. And the next one is, what is the next one? Buffer overflow 0. Okay.
Open it up. Let's have a read.
All right. So,
no, that's a CVE.
Yep. There we go. Buffer overflow 0. Okay. So starting off simple, can you overflow the correct buffer? This program's here and the view source is here. So you guys are going to see on all the buffer overflows, they give you the program and they also give you the source. The reason for that is so that you can run it on your own machine and basically attempt this without just sitting here or connecting to netcat over and over and over. All right, so let's hit the hint. How can you trigger the flag to print? Okay, it's not much of a hint since we already know it's a buffer overflow. If you try to do the math by hand, maybe try and add a few more characters. Sometimes there aren't things you are expecting. So if you guys aren't familiar with buffer overflows, the reason they're saying that is because almost every time, even if you did the math and you know the buffer is, let's just say 10 characters just by chance, there's going to be padding added there. So might be 4 bytes at the end or something like that. So you have to figure out the padding as well. So that's why they're saying add a few more if you think you've got it down. Run man gets. Okay, so this is a big one. I actually didn't read that hint, but I do have that in my notes and I'll show you why. So before we even look at it, we'll go ahead and run that. Man gets.
That's a
okay.
C.
Yeah, so this here is a function that we're looking at, but we can see it here. I know it's in here. Right here. What's this say? Never use gets. Okay. So it's impossible to tell without knowing the data in advance how many characters gets will read. And because gets continue to store characters past the end of the buffer, it's extremely dangerous to use and has been broken. Okay. So that's a big hint. That tells us basically that we're probably using gets. So let's go ahead and download these 2 files. let me cd into this is buffer overflow. Let's make one. All right, so we'll wget it. And this is the actual file itself, not the source code. And then we'll do the same thing. And then we'll have the actual file and the
.c file, which is
and the code. So before we even do anything, let's go ahead and run it and look at it. So we have to change mod, and it's just called vuln, and we'll just run it and see what we get. Okay.
So you need the flag.txt.
So yeah.
Nano
let's go ahead.
.txt.
Yep. So we can just do whatever. It doesn't matter yet. Touch flag.txt. It doesn't matter. Okay. So vuln. Okay. Input. So let's just put A. See what it gives us. This program runs now. Okay. So it didn't really give us much. Now, knowing this is a basic buffer overflow, let's just put a bunch of A's and see what we get.
You're going to get nothing, hopefully, because your flag.
And I got nothing. Yep. So that means we did get it, even though it doesn't make sense because our flag.txt, if we cat it,
it's nothing.
Is nothing.
Just put something in it. Come on. Put nano flag.txt. Put
so
hi
we'll just do hi. And we named it flag.txt. Okay. And we'll just do a bunch of A's again. And there's our hi. So it clearly is reaching out. The buffer overflow is working and we're getting our flag. So now if we netcat to theirs and we see input, let's just put a bunch of A's and C. Okay. So one thing you can do manually here, if you wanted to really do the math on this, you could just go through and start with 1A, start with 2A's, 3A's, so on and so forth, until you start to see this buffer overflow, meaning until you start to see this information come out, until it reaches that flag, because it's calling on that flag function with the overflow. Now, with this one, I purposely didn't show you guys the tools because we are going to cover more advanced buffer overflows, and there's no need to get crazy advanced with this one as long as you understand what it's doing. So let's go ahead and paste it. Boom. All right. And if you ever see gets, you now know that it's extremely insecure.
Yeah. Should we do like CVE-XXX at the end? Because these are all buffer overflows and the CVE-XXX is like a bit of research.
Yeah, we can do that. Yep. So let's just hop right into buffer overflow 1. All right. So let me make, I think I already have a, yeah, I think it's just overflow. All right. So clear. I think this is, hopefully this is the one. We'll just make a new one because I'm not sure if this is the right one.
Okay.
Buffer
1.
Yeah. So maker buffer 1, CD buffer 1. All right. So we're on buffer overflow 1. We got to launch this instance. So you don't get any hints or anything until you launch this, just heads up. And I think it's got a 30-minute timer. Yep. Okay, perfect. So now we need the program. Before we even start, we always need the program. So we'll need the program and the source code. And then we'll go ahead and get the source code. Then we'll go back and we'll actually read it. Okay. All right. So now let's read it. Control the return address. Okay. So that's a hint in itself. Now we're cooking. You can overflow the buffer and return the flag function. So it kind of tells you exactly what you need to do, which is a big hint here. So now let's read the hints. Make sure you consider big Indian versus small Indian. Okay. So this is a big hint. If you're not familiar with the big Indian versus small, it's just in reverse. So what that means is when you put hex in, because our address is going to be in hex. And when that happens, it needs to be in reverse is basically what they're telling you. So we'll see when we get there, but changing the address of the return pointer can call different functions. So they're kind of laying it out for you really. But we'll go ahead and we'll look at the code first. So let's make sure we got, All right. So first things, we have to always change the permissions of the file. So now we can just go ahead and we'll still vuln c or cat the vuln.c to just to look at it and see what we've got. Okay. So it's pretty small. All right. So you can see, looks like the win function here is what opens the flag.text. So if we're going to test this on ours, right?
Just hold on 1 minute. Like the core issue here, guys, is that see that win function, that the program will never get to it, right? If you look at the main, there is no calling. If you scroll down and see the whole main function, this is the only thing that runs when the program runs. And there's you set some buffer, you get GID. I don't know actually what that does, but at no stage, if we have this getty GID function, I don't think that calls, is that something that we have in the program? But I don't see no calls to win, right? And that's what we need to do. We need to basically run the win function somehow. And that's how we're going to solve this, unless Stuffy knows something I don't yet.
Nope, that's exactly how. So somehow we need to get it to call back to that win function. So really the first thing we have to do is we have to get the location of that win function in the code. That's the first thing, because we need to point it to that, right? So let's go ahead and let's run the file and just look at what it's going to do for us. So first things, we have to create that test file again, right? So we'll just say echo flag test, right? So if this prints, then we know that we're good. We've got it. So flag.txt. Okay. So now if that flag.txt prints, then we've got it. So I'm going to assume we don't have it here, but let's go ahead and run it to see what it is like. Please enter your string. So the last one, we just entered a bunch of A's. Let's see what happens if we enter a bunch of A's. Ooh, nope. But
seg fault.
We get a seg fault for one. The other thing we get here is this in hex. I'm assuming that stands for AAAAA, which tells me that it's reading this, which is good. So now what we need to do, let's go back and look at the source code, because this one actually tells you the buffer size is 32. Okay, so a lot of people would think like right away
32 bytes.
Yeah, so a lot of people would think that's the number we need, right? But like I said in the last one, there's going to be padding there. So even though it tells you, we have to figure out the exact number of characters that we have to enter in order for it to get to our destination. So let's go ahead and clear this.
If you I was going to say, do the AAA, do the AAA again, just run it. I wanted to illustrate something for the people out there more. And where are my annotations? Seg fault. Okay. So the idea here is with that 32, this is how far I was able to follow when I was trying to solve these things myself. In theory, assume that my thing is 32, right? Like, let's say that's 32 A's.
Yep.
The blue box right here and the address being, 0x, I think that could be 4 hex. I think there's 2 letters per letter. It doesn't really matter. But the idea here is this is your buffer. That's the overflow. Yep. And there is a place where the return address. So like the buffer, when it overflows, it overwrites a part of the register where the return address of the program is stored. And then if instead of returning to the end of the program, start of the program, whatever you programmed, if it goes to the win function, that's how we win. Unfortunately, there's quite a few technicalities between the theory. For one, you don't put 32 letters and then the address. For second, there's some sort of a reverse writing of the address. And third, we don't even know the address. So that's what Stuffy's going to solve.
So that's a perfect example is like, let's say this is what we need, the amount of characters we need before our buffer. And then we need to put the address in here. But like he said, there is technicalities there. So like the big one with the hint is make sure you have consider big Indian versus little. So just by saying that, I'm pretty certain we're going to have the address backwards, because big endian versus little, that's the only difference, is one's in reverse, and they wouldn't tell us that if it wasn't going to be in reverse. So that's kind of a hint. So first things first, obviously I would not sit here and type A's. That's just because it's kind of a waste of time. So I would use a tool called Cyclic, if you guys haven't heard of it. So all it is basically a tool that's going to do exactly that. So it's going to print off whatever I want it to be. So like if I do Cyclic 100, you see it just prints off 100 random characters. So it saves me from typing A forever, you know? So I would do Cyclic 100 and Volm, right? Because I'm going to go ahead and input it, and we're going to get, you know, you can see here, we've got some A's in there. And then so basically we see the same thing. It just saves you a little time if you're trying to do this a little bit more manually. So now the other thing that's really cool about Cyclic that we can do is we can take this right here, copy it. We can say Cyclic. Okay. And what we're going to do is we're going to say we want the location of this, because this is our buffer basically, because that's where it's jumping to. It's giving us the hint. So now we hit enter. Okay. So now we have our destination. We know it's 44. Okay.
44.
Yep. So we'll go ahead and copy that just to keep that just in case. So you can see now we have the location. Now we have what we need. We need at least 44 characters. Okay. So now we need the actual location of the hex basically, right? Or we need to, where we're going to jump. What do we have to put in there? So that's the kind of the key here. So what we need to do is go ahead,
get the memory location of the win function, which.
Yep, that's exactly what we need. Is we need the memory location of the win function. So we have our actual 44 characters. So usually I would have this in like a notepad and I'd be writing this stuff down so I don't have to copy it and worry about it. But now we can go ahead and we can basically take if we go back to the, what is it called? The volm.c. So now I just want to show you guys this. So this is what they set as the buffer size. 44 is the actual size after the padding and everything. So that's why we have to calculate it, because if you just try to use 32, or what was it, 36, 32, then yeah, you're just going to be stuck. You're not ever going to get anywhere. So you have to calculate that. So just keep that in mind, guys. Okay. So now we have the calculation. So now what we need to do is find the location of win, the function. So we're going to use object dump. And what this is going to do is give us all the locations. So object dump, tech T, and then the Volm, which is the file. And we could just run this and I'll show you guys. It gives us all the different ones, but we could do the same thing and then grep for win, right? And then we would get our location. So a bunch of crap. So if we just go ahead and do the same thing, but then grep it and say we want win. All right. So we have it there. We have our location. We don't have to actually do that again, right? So there's our location. Wow. All right. So now this is the location of where we need to point to, right? Because that's the function we want to run. So we want it to run that win function. So we've got 44 as our number to hit, and then we have the location. So now it's kind of easy at this point. So now we just do cyclic 44 because we need the 44 characters. And then I have the location there that I will actually just open a notepad and throw it in so I don't lose it. And then here's our 44 characters that we can copy. And we can just put it right here.
Have you reversed that yet? Have you big?
I haven't yet. That's what.
Not yet. Okay.
Yep. That's why I did it here, not in the terminal, because I don't want to have to try to, because terminal doesn't let you move around really, like click around.
Yeah.
So yeah. So now this is where you think you probably have it, right? So then you would go ahead and put this at the end, and then you'd be like, oh, it's not working. Well, that's because we have to reverse it. So that's kind of the whole point. So instead of what we think it'd be, which is 080491, it would be F6 X F6, because you're doing hex. So X F6, and then X91 over and X08. Okay, so that's what we need to do. So now that's reversed. So keep that in mind that this, if it's big Indian versus little Indian, it's reversed versus here would be the normal. So now we have that, but because this is in a different language than
you are
by default, we have to use print. What's that?
Unfortunately, I don't know. Do you hear me clearly?
Yeah.
Okay. You were breaking up on my end a little bit, but it's okay. We're recording in 2 places. So,
okay. Hopefully, yeah. Let me know if it does it again, but cool. All right. So since we're using a binary in C, we need to print F, because if we just did, just echo or whatever to it, then it's not going to work. So there's our actual, what we need, right? So we need to print F, and then we need to feed that into our actual binary. Sorry.
Da, da, da.
All right. All right. So again, so here's the actual destination, but now we need to feed that into the actual vuln. And then if it works, we should get our flag, which I think was flag test or something. Okay. So it didn't actually work. So what did we do? Let's look at it. Oh, I know what I did. I didn't even put it in quotes.
Ah.
All right.
Because that was a bit.
Flag test. There we go. So
nice.
It prints our flag because it's pointing to that win function. So now that we actually have that, we have to somehow get that all the way to this netcat listener. So this is where it gets not tricky, but you need to know a little bit about the terminal to get past this point, because if you just try to print F and pipe it into there, it's not going to work. So you have to do a little bit of finagling to get it to take the way. Now you could write, I noticed when I looked at other walkthroughs, like a bunch of people wrote scripts, the Python scripts, and use Pwn tools and stuff like that. And that's really cool, but it's not that difficult to do. So I just thought this is a little bit easier. So we'll go ahead and just change these to quotes so that way I can add. So basically we're going to say, okay, right there's the end.
Okay.
And I mean,
I don't, sorry, yeah.
So yeah, so it's just ending the statement, and then we'll say cat, because it's just going to cat it for us basically. And we have to, because of we're doing multiple statements in this, we need to put them in brackets. It's just because we're doing multiple, because we're still going to netcat it into this. But the difference is here that we're just going to say print this and then cat it for us as if we were reading it. So then we'll just do our regular netcat Saturn. Well, we got to pipe it. So then we're putting it into this command, which is going to connect us ctf.net 50646. And then if we did it right, enter your string, and you got to give it a sec because it is going to then read it to it basically.
I still don't fully understand like why these are not pasteable. Like,
you mean, I agree.
There's 40 characters. Those are hex
like
locations.
Connection froze.
Yeah.
I tried and it would not take. I'm not saying that I don't agree with you that it should be. I don't know why it's frozen now. My connection just like died on it.
I think that I have seen some walkthroughs and people had to use Python 2 instead of Python 3 because the print statement in a Python 2 produced the valid input and Python 3 didn't. And yeah. I don't know. I think we might need to make sure you copy.
There we go.
Oh!
I had to hit enter to continue it for some reason. So there you go.
There we go. Wow.
For some reason it just get stuck and I had to hit enter to enter it. So there it reads it. And then addresses are easy. And then I don't know what that last word says. So there you go. That's your basic buffer overflow. And I'm going to send you a link to a really good site that explains buffer overflows for anybody that wants to
please do
try to learn them, because it is.
If I would recommend, there are 2 videos by Computer File, one on stacks and another on buffer overflows that have helped me a lot. And that's also a really good A really good channel.
This is by Null Byte, if you know who they are. But yeah, it's an older one, but it explains it very well. It explains it in kind of layman's terms. Super. All right. So now the last buffer overflow, because RPS is not really a buffer overflow, so I'm not gonna do that one yet. I'll just skip to the X60 because it is more of a buffer overflow.
Cool.
All right. So we're going to do X60 next. So this one here is pretty much just like the overflows we've done, except for I'm going to use Metasploit tools instead of the cyclic that we used. But the only difference here is, and they give it to you, is the overflow is the 64-bit rather than the 32-bit. So there's a little bit difference here that we've got to do. One thing I will mention here is in the hints, they give you what used to be 4 bytes, now maybe 8. So that's a big hint because you're going to need that. And then this secondary one is a must. It's not a hint. It's just a heads up that you have to go to the second instruction. You can't do the original and the flag.
So Stuffy, just to ask one question to clarify for the hint number 1, if you go clean what used to be 4 bytes is now 8. Does that basically mean that the address itself is an 8-byte address? That's
yes.
Right.
Yep. So we'll have to pad it basically is what we'll have to do. So we've already got the download, the source code, and we've named it vuln. So if we go ahead and just run it and see what it gives us, welcome to 64-bit, give me a string that gets you the flag. Okay. So we'll just say hi and see what it does. Okay. We don't have anything. So first thing, let's make a fake flag. So that way we know hello. So that way we know if we get it right. Hello flag. And we'll name it flag.txt that way. And of course, and the reason I keep getting that error, you guys will see, is because this folder is owned by root. So we'll just sudo su, and then we'll just go back into it.
By the way, not best practice to just do stuff as root. But
no, it's not best practice at all. So the tool that I'm using, the GDB, was not cooperating with me without root permissions. So I had to run it as root. And when I did that, it created this folder as root. So let's go ahead and, we're now in root. So now we have to do it again. So echo hello flag, and we'll just name it flag.txt.
Just
all right.
An important thing though, we are assuming that the actual C program, and do we have it if you ls?
Yes, we do have it. Yep. Right here, vuln.c.
Can you cat it just to make sure that it's actually calling on flag.txt?
Yep. And there you go. So you can see what we're trying to do is run this function right here that will call on flag, and it tells you here, please create flag in your directory. So that way, you know that because otherwise you would just get nothing and you wouldn't realize that you've even beat it probably. So one thing we notice here is the buffer size is 64. So they actually give us that, which that is correct. So there is no padding on that one. So that's kind of interesting. Now we'll go ahead and clear it. So first thing we're going to do is we're going to just do the same thing we've done in the past, which is go ahead and send it a bunch of characters and see what happens. So the way we're going to do this is a method that is called fuzzing, and I'm going to show you guys. So I'm going to use Metasploit to create, instead of cyclic, which we used in the last one, just so you guys see a variation of the same tool, or a variation of tools that does the same thing. We're going to use Metasploit, and what it's going to do is it's going to create a pattern, and basically however many characters I tell it to, which is length, and I'll tell it, we'll just say 1,000, and we'll just name it test. Doesn't really matter. All right. So now you can see here, if I cat that test, it's just 1,000 characters, and it created a pattern. The pattern doesn't really matter because we're just feeding it random. So now what we're going to do, if we open this up, is we're going to use GDB. Okay. And we're going to say in the GDB, actually, we're going to have to quit the GDB and go into that directory.
So you're going to feed the pattern into the flag program. GDB is going to give you a segfault, but you're going to know in which memory.
Yep. So GDB is a tool that just is a debugger, right? So we'll get rid of this. That's from the old one, or the other one. And then we'll just say R. So in GDB, R will just run the file. And when we run it, we want to feed it in that test, because the test is just going to feed it those characters, right? No specified. Oh, yeah. So I didn't specify when I ran GDB. So we're going to say GDB, and then vuln is the file name. And then now we're going to run, and we're going to feed it the test. Okay, so the seg fault is what we kind of expected. We wanted it to crash the system because we wanted it to, do the overflow. So when it did that, it gave us this location, which we'll need. And that's the location of that function, which is what it's actually calling upon. So we needed that. So now the next thing we're going to need, is we're going to actually have to go in here, and we're going to have to get the location of the RBP. So what that is in the stack, that's going to be the pointer that actually points to the return function. So that's going to be what we need to actually point to say, grab us, our next location, which is going to be the flag function. So what we can do to do that in GDB, because GDB is a great tool, we can just type X and $RBP. So the $sign just acts as basically kind of like in Linux is a variable. So what I mean by that is, if you were to look at all locations, the RBP would be labeled with the money sign. So that's why it's there. All right. And then there's our address. So this is big because now with this address, we can actually calculate the offset, meaning the actual buffer size. So the buffer size, I know it said 64 in there, but typically there's padding added for different things. So I wouldn't trust just because the code says 64 that is the 64, but you can if you want, but you might waste a lot of your own time doing that.
And just to clarify, our address, our goal is to effectively have RBP point at where we want it to point, and which is the flag function, but not the top of the flag function. Yeah, just underneath. Yeah.
And you'll see that here. All right. So this next tool it's right next to the other tool. If you go to that drive on Metasploit when it's installed, and what it is it's taking that pattern that we gave it, and it's now we have the location of the function that we're trying to find, which is the RBP. And so we can feed it that location and say, what's the offset? How far do we have to go to get to this pointer function? So when we feed it that, which I think I copied it, but let's make sure. Copy. And we can say with the offset right there. And we can say, basically, give me the offset, right? So when it gives me the offset, it's going to feed me the exact buffer. And offset is at 64. So that's good. That's what it said it was at. But usually there is padding in there. So we had to check. So that's good. We have the buffer now. So we know that we need to specify at least 64 characters, right, before our payload, because otherwise we're not going to reach that offset. Okay, so now we've got that. All right, and now what we're going to do is just use the same tool we used in the past one, which is object dump. And we're going to say object dump, and we're going to say d vuln, and this is going to give us our actual exact locations of our functions. Now, usually you would go to the flag, which is up here. I know I saw it here. I might have went past it because I thought it was right here. And I would grep for it, but if you remember, yep, here it is. There it is. So if you remember, we have to actually go to the one past the push in flag. So interestingly enough, this is the flag function, the 36. We're actually going to the 23B here because they tell us to. That's really the only reason we know. I'm not sure what they've done or why it's like that, but they tell you, hey, if you try to actually specify the flag, you're going to get an error. So I'm sure that racked a lot of people's brains if they didn't read that. So now we go ahead.
We got to write the reverse one with the padding.
Yep.
So
now what we'll do is we'll go ahead and write this just with the reverse. So we'll go ahead and say X3B, and then we'll say X12, X40, 40. Then from here, because if you remember, they gave us that little hint that said it has to be 8, not 4 like the last ones. We have to do X. 00 x00 x00 x00. Whoops, not 99.
7. Done.
All right, so that is our actual location that we need. So we'll keep that because that's going to be handy. We're going to need that, right? So now that we have the actual location, and we know that because we're using the little Indian, we have to go in reverse like that. Let's go ahead, scroll down to this, clear this out so we have a fresh, clean install. So now one thing to keep in mind is because we aren't going to our original function, we need to add 8 to this because we need to add one more, basically 8 bytes to get to the next one. So we're going to say 72, and it's either 72 or 80. We're not 100%. So we're going to try 72. And then if that works, awesome. If not, we'll try 80, but we know we've got to add that. So, all right. So now what we're going to do is we're going to do a simple little script that will test our local machine or our local vulnerability. And if we get it, then we know which our flag.text is hello flag. So if we get that, we know that it worked. And then we can actually make this a payload for a larger attack on the netcat listener. So let's go ahead and do our Python 3 attack C, and we'll say print. And then we'll just do, and it doesn't matter what you put here, but we're going to just put A's. That's pretty much standard, pretty easy. We're going to say 72. So we need it to print the 72 A's, and then we need it to plus the address, which I don't know that I have copied still, so we'll make sure. All right, so we've got that printed. And then we close the bracket. We'll say end equals
nada.
Yep, and then whoops, close it. And then from here, we'll name this payload. Payload. Doesn't really matter what you name it. So we'll name it payload. And then on the GDB, if you remember, this is still running. We'll quit. So that way we get a fresh run of the file. And if you remember last time we did the interpreter payload, we're going to now feed it our payload. And you can see right there, we got hello flag. So perfect. So it actually got our flag based on that location. So we know it's 72. We're good there. So now we just have to get this to the netcat listener to take this, which it's not going to take it the way that we had it because for some reason it doesn't like it. So
yeah,
we'll go ahead.
In one of the challenges that the simplest script I could think of, I was trying to brute force it via the netcat, and it was yeah, the netcat listener isn't as reliable as there's a reason why they give you the file to try it locally first. Yeah, so you know
exactly.
So you know that if your method is right.
Yep. And I actually, so when I did this, I actually had it. I had this and I was working with it, not the script. I had the payload and everything, and I could not get this netcat listener to take it. So I actually had to look it up. And when I looked it up, I found this guy created this script. I've deleted some of the stuff he put in there because he was using this script for the local exploitation too. So he had some more stuff in here, but I had already done the local exploitation. So yeah, I had to use the pwn imports and his script, which if you look up pwn imports, they're pretty good. That tool set is pretty good about doing this. And I've seen a lot of people do these buffer overflows with scripts very similar to this. So this is good to have. So the way it's going to read, pretty simple. Here's our payload. It's the A times 72, then our address. And then you can see there's our destination. And then pretty easy. It's going to print out the received line. And yeah, pretty basic, pretty easy. We inserted the destination, but one thing I will have to change is this port because it changes every time you start it up, I believe. So let's go ahead and take a look at what our port 61187 is the port. So we'll have to change that 61187, and then we'll save it. And then we should be able to just run it. And there you go. There's your flag. It sent the payload and we got it right back.
Wow. That was like, that's hard work. And yeah, I think the part that really gets me is the fact that like the netcat listener isn't going to take the information you actually type in.
Yeah. It's funny because if you remember in some of our first videos, you were asking me a lot about netcat, and I was telling you it's not used as much as you think to do some of that stuff. And that's why, because it is not as handy as you think. Now it can be very useful, but yeah, usually if you have, like, let's say you do a reverse shell in netcat or something, you're going to try to instantly make that a more stable shell. You're going to try to get like a Metasploit or Cobalt Strike or a Covenant or something like that, that will make a stable connection that you're not worried about crashing and messing up and stuff like that. Netcat's just not very stable.
I guess, you know, it's probably a free tool and the development team isn't really like, it's probably just a script somebody wrote 10, 15 years ago.
It's been around for a long time. Yeah, as I say, it's been around for a long time, and I don't think it's changing anytime soon.
Yeah. Okay, so we got one more buffer overflow. Did you say you've had
that's
another one?
All. No, we've got RPS now.
RPS, excellent.
Yep.
You show us how you did RPS. I've done a little script that I was really proud of until I realized that there were even simpler solutions.
So I don't even know if I created a thing for it. I did not. Okay, so we'll make a directory real quick. RPS, CD RPS, and then we'll open up. That's the wrong one. We'll open up RPS and we'll download the source code. Make sure, yeah. And then from here, all you got to do when you see the source code is kind of take a good look at it, I guess. It's called game redacted. Okay, so if we look at it, we'll open it in a text editor. I didn't realize it was that long. And
I need to read.
All right, so looks like flag was redacted. Okay, if I can scroll here, there we go. Okay, so let's see where we're looking, where it's actually going to read our
ready for reading
for user input. Okay, so here's the bool play. Please make your selection, rock, paper, scissors. Okay. Looks like they have a timeout. Here it is. Okay, so if string player turn loses computer turn. Okay, so and then the computer turn is obviously random, right? So you're probably, I think you said you actually did the statistics on it. Like,
yeah. 0.41% chance of getting 5 in a row. So
yep. But if you look at it, it actually is, it will accept, you can see it, and it's going to give you these options, and the options are rock, paper, scissors. But it accepts, it's a string within a string. So it accepts, it's just checking to see if that's in there, right? So it's checking to see, is rock, whatever it chooses, whatever the random winner is rock in there, is paper in there, is scissors in there, whatever.
Can
whatever
we see the code where it sort of matches up? Is it string toll? Like, where is the thing where it goes null input, put in a valid number?
Right there. It's, for some reason, it's glitching out on me when I move it there. But all right, so this is the same string that we had before, which is the string toll input null, wins 5.
Where's the win checker? Like I thought
I just saw it. I could have sworn I just saw it. Seems like you didn't win. So here we go. So if the string within the string is the player's turn compared to loses, computer's turn. Okay, so if your string, which is the rock, paper, scissors, whatever it chooses as the random, and then the player's turn, basically, yeah. So if your turn compared to theirs is the winner, so if rock, obviously beats scissors, so on and so forth, else it seems like you didn't win, right? So if that's true, meaning the string inside of the string is true, meaning if your string is the winning string, which is rock, paper, or scissors, whatever they choose randomly, then you win, which then it'll print out you win. Else, seems like you didn't win. And then down here, you can see if the wins gets to equal or greater than 5, you get the flag. Now, one thing that actually had me interested is I didn't realize that it had this string toll function. I wonder if we could get it to print that based on what we did earlier.
Oh yeah.
If there's another
solution
issue in there. Yeah. But yeah, so we can go ahead and so there's a lot of ways to do this. Obviously, the way you did it is just brute force it, and it probably doesn't take that long because a computer can do so many tries so fast. But the way I did it, which is, I don't think we actually have the game, do we? We have to actually click on the game. They didn't give us a version of the game this time. All right, so we'll just go ahead, get rid of that one. All right, so we'll just go ahead and netcat in. We're going to play the game. All right, so please make your selection. So the first time I did this, I actually got to 4 and I thought I was like going to win it. And I was like, oh, I don't have to do anything. But then I lost. So the nice thing is because we saw the code, the way it works, it's just looking for a specific rock, paper, or scissors inside the string. So if we type rock, paper, scissors, it's going to always find whatever the winning is, whether it's rock, paper, or scissors. So look, the computer played paper, we win. So now we play again. Rock, paper, scissors. And we can just keep doing this until we reach 5.
And then it'll give us the flag.
As long as you don't mess up and type something wrong. And, oh, we got one more. And it'll keep printing the flag because if you remember, it's got to be greater than or.
Yeah.
And you can see it says some extreme luck.
Yeah.
So,
yeah.
I wonder, I'm sure they have people that just try and do it and get lucky. So I'm sure that's part of the.
If you do it, 0.41% evaluates to something like 250 or something. So at 250 times, you have about a 50-50 chance to get it. I mean, stranger things have happened.
I'm sure there's someone that's logged in and just did it first try and no.
Let me show you mine for a second.
Yeah.
I'll bring that up. Do you see my Kali here?
Yep.
So just like you, I mean, I was looking at a script, funnily enough, of somebody who hacked the system with time. So they managed to simulate C inside their pawn tools and then use the random seed to predict the computer move and then decide their move based on the computer move. It was rocket science. And I was
deep.
Yeah, they went in deep. And I'm like, look, I think I can understand because I'm new to pawn tools, but I'm like, I think I can understand this whole thing, how it works. So like, why don't I just keep playing it? And the biggest problem I had initially was that it took thousands of tries and the terminal would just sort of crash because it was pretty much text. And so I managed to create this string variable receive data, which basically takes the printout of the whole game. And only print receive data if the PicoCTF was in it.
Okay, so just wait till the winning.
So all I did was select one to play the game and then send the payload, which was just a random choice. And obviously, if ever PicoCTF was inside the printout after the payload, only then do I print it. And so like that was Python. So it's rps.py. That's the name of that. Python 3 rps.py. And
there it is. Yep, right in the middle.
631 tries. And there's the thing. I mean, every time you run it, like I've had as little as 100 tries, you know?
It's just.
Let's see. 198.
Yeah, 198. That's pretty good.
Right. So like it's highly random. Eventually, like I said, if you played it long enough, eventually you'd get lucky. But yeah, that was, and funnily enough, I was very proud. And I was even going to write it up and show people my solution until I saw the one that you just showed me. And I'm like,
That's still a pretty good solution. I mean, that's pretty, because even if they didn't have that vulnerability, I mean, you'd still beat it.
Yeah,
so that's the thing. Yours isn't really necessarily a vulnerability, which is kind of interesting. You just actually beat it.
Well, I mean, once you calculate the probability of winning, if this was like 10 million times, you would expect maybe, I don't know, netcat to throw you out or something. But I'm like, a couple hundred. I honestly thought I might have to run it. Like it wouldn't solve it every time. I would have to get it in a couple hundred and it wouldn't accept the thousands. But so that was that one. I think we've only got one left then, which is going to be the research one. And I would like you to, because even though I was able to find it, I stumbled at it through Googling. But like you're in cybersecurity and you sort of have to stay on top of the latest vulnerabilities. And I guess, as you solve the challenge, talk us through the process of like how vulnerabilities tend to be documented and where you can find them and that.
Yeah. I'm just going to the sites here. So this one was, I don't want to say harder. It was weird because you don't have kind of really much information on it at all, I guess we'll say. So the CVEs, the way they're labeled.
Right. Let's
see. I'll share my screen here. Okay. So let me look at it first. So CVE-XXX. Okay. Enter the CVE of the vulnerability as the flag with the correct flag format. Okay. Replacing. Yep. Okay. The CVE we're looking for is the first recorded remote execution vulnerability in 2021 in the Windows print spooler service, which is available across desktop, blah, blah, blah. Okay. So we're not looking for the local spooler vulnerability in 2021. Okay. So it's interesting because the way that CVEs are labeled, right, is based on date. So you could just go 2021 and I'll show you what I'm looking at here. All right. So there's a couple places where CVEs are basically stored, I guess, if you will. So this is the exploit database, exploit DB, whatever you want to call it. And this is where you're going to see like pretty much as they come out. Like exploit database is the leading.
Wow.
And you can see there's 47,000 CVEs.
Entries.
Yeah. So there's an actual process for it to come out as a actual CVE, right? It has to be validated and things like that. People have to understand that it's a genuinely new thing. Like, you know what I mean? It can't be, if you come out with something for an application.
Is a CVE, like, what's the difference between a CVE and a 0-day?
A CVE is published. So a CVE is when like a 0-day happens, like print spooler or something like that. And they go, okay, we've got to categorize this. This is when it happened, that type of thing. So a CVE is published. And when CVEs are published, like databases around the world have them now. So like your intrusion detection systems and stuff like that they're now in their databases. So you now have a way to prevent them typically.
So for example, like the Trend Micro 0-day initiative, and they buy 0 days and then they publish them. Like, I guess after they publish, somebody would put it into this database. If not, the companies that sort of publish 0 days themselves for public awareness themselves would do it.
Yep. Yeah. Cool. So like you can just look, let's just say, and there's another place you can look for them too. And I'll show you this. I didn't even think about, but the thing is you kind of have to know a little bit of information about it, but on Linux, well, not every Linux, but on, Kali, on Parrot, any of these ones, you can just do search exploit. So like, let's say Eternal Blues one, that's pretty common. It's old, but of course I don't have it on here, but and of course, whatever. So all it is it's Metasploit search database.
Got it.
And they have an offline version that you can download. And when you do that, it'll search for basically if it's in their database or not. And if it is, it'll tell you, and you can search by keywords and stuff. So let's go back to the VM and look at what was the information they gave us on it. It was print spooler, I know, but remote code execution vulnerability in 2021 in the print spooler service. Okay, so let's just try to do this. Now, I can tell you, if they gave me that specific information, I would just Google it also.
I Googled it and I found it. That's all I did.
So let's go ahead and see if we can find it. I don't know the name of the title. So that's the thing. We can go to content and we can see if it'll give us that. And we'll see. It may find it. It may not in here because it depends on. So whoever fills it out. So we can just do Windows print spooler service. Whoever fills it out is going to be the one that's going to put as little or as much information as they want. Platform, we could obviously go Windows. And then that's the thing right here. If you knew the actual CVE number, you could find that. But a quick Google search would just tell you the print spooler remote code.
That was the first one. Yeah.
Yeah. And I think they said that's the one they weren't talking about, right? Or is that the one?
I think that's the one they were talking about.
Okay. Because yeah, they said one of them, they said, this is not the one we're talking about.
There are two. I think I might have gotten it on the second try, but there's definitely two that match and they were both on the PicoCTF.
And then
just space the whole thing, I guess. CVE. No, I think we needed the CVE.
Okay. And we'll try that one. Oh, that was it. Okay. I thought that was for some reason, that wasn't the one they were talking about. But yeah, so, and then if you go here, like if you wanted to get some information about it, this is what I always do. I always Google it first just to get the number. And then I'll go here to actually find like the CVE number. So we can search here. You may have to take out the CVE, but yeah.
That's a terrible like search functionality on that thing.
And of course it didn't find it for some reason. Let's get rid of, I might have a filter in here.
Author title.
Okay, so it didn't find it, which is weird. But anyway, you could search for it here on Google. And there's Microsoft's actual thing on it. CVE MITRE is really good. Tenable is I don't know if you've ever heard of Tenable or used Tenable. But Tenable is an enterprise level scanner that I would say 70% of the world uses. A lot of people use it. So they have really good ones. And if you see it on there, it's really good to see because that means it's in their database. So you can scan your system for it. Rapid7's another really good company. That's who Metasploit is owned. Metasploit's owned by them. So this is a really good one, and they'll tell you exactly what I did a whole video on print spooler. It's actually a pretty cool attack. I think it was just if I remember correctly, just a DLL side load, if I remember. But yeah, and this is Microsoft's whatever. But yeah, you can get the summary of it. Yeah, I think it was just but yeah, the print spooler was a pretty big attack when it came out because every Windows machine by default had the service running. So that means every Windows machine by default was vulnerable to it. Wow. Now, if you're not a print server, you just disable print spooler and you're fine. But people don't know that.
I read because I read a little bit about it, and for the first 2 weeks after this got released, the director for Microsoft was essentially, go to task manager, disable the service.
Yeah.
And that was like, really?
Which, I mean, it was better than nothing, I guess. But yeah, I can't believe it's not in here.
Yeah. Well, anyway, that's everything for today, right?
Yeah, that was all of them.
Wow. Okay, guys. I hope you enjoyed that. I mean, as you can see, going through the skills, it's probably not for no reason that binary exploitation is at the bottom one, despite it being B. Like, in my opinion, this is the most technical aspect of at least PicoCTF. Because programming is my forte, and I'm not unfamiliar with C, but this was still a genuine challenge. And as for what Stuffy and I are going to do in the future, we fully plan to finish all the PicoCTF challenges. However, we'll take our time with the harder ones. So it might take 2 or 3 months for every single challenge to be released. With that said, thanks for watching and see you in the next one.
Thanks, guys.